Hello, my name is Evelyn Ramirez. I'm in General Physics 1. My group is Group 5. My teammates are Angel Macario, Abigail Mosier, Clarissa Cerros, and this is our lab report number 9. So the objective for today's lab, we will calculate the coefficients of kinetic and static friction. We will conduct an experiment that will allow us to calculate both friction coefficients using the data. This experiment will be conducting using capstone, sensors, and a measurement device. For the procedure, we first began the lab by gathering the cart and finding the mass of the object that we will be pushing with the cart. The mass will be from the object and a weight that will be set on top. Then we set up capstone and turn on the sensor. We set the cart on the track with the object in front, that way we can do the push. We will record the object being pushed in capstone and use the data to find the static and kinetic force. We did a total of 6 runs for this experiment. 3 of those runs were for a flat surface and the other 3 were for an inclined plane. For the inclined plane, we needed to find an angle where the cart could move. We did use graphs to see where the velocity was constant and also to collect data. For the equations, down here you could see what each variable represents, and all of these variables were used in different equations. So the first variable is F, which is force of friction. U, or mu, is the coefficient of friction. N is for normal force. P is the applied force. M is mass. G is the acceleration due to gravity. A is acceleration, and theta is the angle of repose. So the first equation used is F equals to mu times N, which is the formula for friction. The second equation used is mu equals to P over M times G, which is the formula for the static coefficient of friction. This formula will only be used if an object is on the flat surface and only if it does not move or is at a constant velocity. The third equation is mu equals to tan times theta, and this is the formula for the static coefficient of friction, and it will only be used if the object is in an inclined plane with an angle and it does not move or is at a constant velocity. The fourth formula that we have is mu equals to P minus M times A over M times G, and it is the formula for the kinetic coefficient of friction, and it is only used if the acceleration is different from 0 and if the object is in a flat surface. The last equation that we have is mu equals negative A plus G sin times theta over G cosine times theta, and it is a formula for the kinetic coefficient of friction, and it will only be used if the acceleration is different from 0 and the object is in an inclined plane. All these equations will be used depending on the results that we get after conducting the push experiment after each run.
Materials. For this lab, the materials we used were the program capstone, the passport motion sensor, 2 different carts, magnets on top of the carts to measure kinetic and static energy, a strip for those carts to move on, and a ruler.
for Lab 9. For some background, there were 3 trials on a flat surface and 3 trials on a slanted surface. The velocity was constant throughout all the trials and the acceleration remained 0. U is the coefficient of friction, P is the applied force required to move the object, M is the mass of the object, and G is gravity. And for mass, we calculated 300 grams and gravity 9.81. For our first run on a straight surface, we calculated our force to be 58.70. And then our second run, which is also on a straight surface, we calculated our force to be 70.25. And for our third run, we calculated a 55.82 for force. For our first run for angle, and first, second, and third run, we actually calculated a 0 force because of the tangent equals 0 since there was no acceleration. And that is everything for Lab 9.
Challenges. For this final lab, we faced a few challenges. Firstly, there was only 2 group members who showed up, so some parts of the lab were a bit tricky, especially since we need to record and take pictures while also making sure we did everything correct. Another issue was that our carts were not working and not connecting to the system, so we had to wait for another group to finish before we could begin. Luckily, it didn't take too long, so we were able to get it done. Lastly, since it was just us 2, it was challenging to make sure we were doing the lab correctly and if we were recording the numbers correctly for later reference.